Hello students, how are you? Last time we have seen about how to calculate oxidation number, and under that we have solved many problems. Today we will see oxidizing and reducing agents. Before starting this watching this video, you are expected to subscribe, share, like this channel Alchemist Tube, and then you can start watching this video. Now, oxidizing and reducing agents. In a redox reaction, the substance that causes another substance to get oxidized but itself gets reduced is known as oxidizing agent or oxidant. ምን ማለት ነው? በሪዶክስ ሪያክሽን ከሚያካሂዱት ሰብስታንሶች መካከል ሌሎች ሰብስታንሶች ኦክሲዳይዝድ እንዲሆኑ የሚያደርግ ነገር ግን እሱ ራሱ ሪዲዩስድ የሚሆነው ሰብስታንስ ኦክሲዳንት ወይም ኦክሲዳይዚንግ ኤጀንት ተብሎ ይጠራል። ኦክሲዳይዝድ እንዲሆን ለዛኛው ሰብስታንስ ኤጀንት ሆኗል ማለት ነው። ኦክሲዳይዚንግ ኤጀንት ወይም ሰብስታንሱ ኦክሲዳንት ተብሎ ይጠራል ማለት ነው። In the same manner, the substance that causes another substance to get reduced but itself oxidized is referred to as reducing agent. ይሄኛው ደግሞ ሌላኛው ሰብስታንስ ሪዲዩስድ እንዲሆን የሚያደርግ ራሱ ግን ኦክሲዳይዝድ የሚሆነው ሪዲዩሲንግ ኤጀንት ተብሎ ይጠራል። ኦክሲዳይዝድ የሚሆነው ሰብስታንስ ሪዲዩሲንግ ኤጀንት ነው። ሪዲዩስድ የሚሆነው ሰብስታንስ oxidizing agent ነው ማለት ነው። In other words, oxidizing agents are substances that are reduced or gain electron. Oxidizing agents substances that gain electron. Oxidizing agents are substances that contain elements whose oxidation number decrease. On the other hand, reducing agents are substances that are oxidized or lose electron, or reducing agents are substances that contain elements whose oxidation number increase. ምንድነው የሚለን? ኦክሲዳይዚንግ ኤጀንት የምንላቸው ሰብስታንሶች ሪዲዩስ ይሆናሉ፣ ሪዲዩስድ የሚሆኑ ናቸው፣ ወይ ደግሞ እነሱ ሪዲዩስድ ሆነው ሌላኛው ሰብስታንስ ኦክሲዳይዝድ እንዲሆን ያደርጋሉ። እነሱ ኤሌክትሮን ጌይን ያደርጋሉ። ጌይን ኤሌክትሮን አድርገው ወይም ኦክሲዴሽን ነምበራቸው ሪዲዩስድ ሆኖ ሌላኛው ሰብስታንስ ኦክሲዳይዝድ እንዲሆን ኤጀንት ይሆናሉ ነው የሚለን። በሌላ በኩል ሪዱሲንግ ኤጀንት የሚባሉት ኦክሲዳይዝድ የሚሆኑ ሰብስታንሶች ወይም ኤሌክትሮን ሉዝ የሚያደርጉት ሰብስታንሶች ናቸው። እነሱ ኦክሲዳይዝድ ሲሆኑ ሌላኛው ሰብስታንስ ሪዲዩስድ እንዲሆን ኤጀንት ይሆናሉ ነው የሚለን። Electronegativity. Elements with high electronegativity are good oxidizing agents. For example, fluorine, oxygen, nitrogen, chlorine are good oxidizing agents, good oxidants. More electronegative element ከሆነ ኤሌመንቱ it is a good oxidant ነው ማለት ነው። Whereas elements with low electronegativity are good reducing agents. ኤሌክትሮኔጋቲቪቲያቸው ሎ የሆኑ ኤሌመንቶች they are good reducing agents. ጥሩ reducing agent ናቸው ማለት ነው። አሁን ኤሌክትሮኔጋቲቪቲያቸው ሃይ የሆኑ ኤሌመንቶች they are good oxidants ናቸው። ኤሌክትሮኔጋቲቪቲያቸው ሎው ኤሌክትሮኔጋቲቭ የሆኑ ኤሌመንቶች ከሆኑ they are good reducing agents ናቸው ማለት ነው። For example, sodium, potassium, magnesium and aluminum are good reducing agents, whereas fluorine, oxygen, nitrogen, chlorine are good oxidizing agents ናቸው ማለት ነው። The other one is oxidation state. In a compound or ion, if one of its elements is in a higher oxidation state, then it is an oxidizing agent. Similarly, if an element of a compound or ion is in a lower oxidation state, then it is a reducing agent. ምን ማለት ነው? element of a compound or ion lower oxidation state ካለው it is oxidizing agent ነው, reducing agent ነው። በሌላ በኩል higher oxidation state ካለው oxidizing agent ነው ማለት ነው። For example, these compounds are good oxidizing agents. Potassium permanganate, sodium chlorate, potassium chromate, and the like are good oxidizing agents, whereas iron sulfide and carbon monoxide, sodium sulfide are good reducing agents ናቸው ማለት ነው። Analyzing redox reactions. Oxidation and reduction reactions are called redox reactions in short. Oxidation and reduction reaction takes place simultaneously in a given reaction. If there is no oxidation, there is no reduction, and vice versa. Let us see examples. Identify the oxidizing agent and reducing agent, the substance that oxidized and the substance that reduced in the following reaction. Hydrogen sulfide reacts with bromine, gives us hydrogen bromide and sulfur. Now, first let us assign oxidation number to all the elements of the reactant and product. In the reactant side, the oxidation number of bromine is 0. The oxidation number of bromine is 0. Here is it. In the product side, the oxidation number of sulfur is also 0. Here is it. The oxidation number of hydrogen in the reactant side is +1 and also in the product side also +1. So bromine is reduced from 0 to -1, while sulfur is oxidized from -2 to 0. Now አሁን እዚህ በምናይበት ጊዜ ሰልፈር ከኔጌቲቭ 2 ወደ 0 አቅንቷል። ብሮሚን ከ0 ወደ ኔጌቲቭ 1 ወርዷል ማለት ነው። ስለዚህ the substance that oxidized is reducing agent while the substance that reduced is oxidizing agent. Oxidized የሆነው substance reducing agent ነው። ስለዚህ oxidized የሆነው substance sulfur ነው። Sulfur is oxidized. From the above diagram that we have seen, the oxidation number of sulfur is increased from -2 to 0. Therefore, it is oxidized. Bromine is decreased from 0 to -1. Therefore, it is reduced. Hydrogen sulfide is reducing agent because the substance sulfur that oxidized exists in hydrogen sulfide, while bromine is oxidizing agent. Hydrogen has no change and it is a spectator. Hydrogen ምንም ለውጥ አላሳየም, therefore it is spectator ነው ማለት ነው። Example 2, write the oxidizing and reducing agent for the reaction given below. Copper react with nitric acid to produce copper nitrate and nitrogen monoxide and water. In this reaction, the oxidation number of copper in the reactant side is 0. However, in the product side is +2. Therefore, copper is oxidized because it increased from 0 to +2. The oxidation number of hydrogen is +1 in the reactant side. It is also +1 in the product side. There is no change. The oxidation number of nitrogen in the reactant side is +5, while in the product side with copper nitrate +5, the same. However, in nitrogen monoxide is +2. Therefore, the oxidation number of nitrogen is reduced from +5 to +2. Oxygen is the same in the reactant side and in the product side. Therefore, the oxidation number of copper is increased from 0 to +2. Therefore, it is oxidized, and therefore copper is reducing agent because the substance that oxidized should be reducing agent, and the substance that reduced is oxidizing agent. Nitrogen is reduced from +5 to +2 in nitrogen monoxide, and nitric acid is an oxidizing agent ማለት ነው። ስለዚህ ምንድነው ኦክሲዳይዝድ የሆነው ሰብስታንስ ሪዱስ ለሆነው ሰብስታንስ ኤጀንት ነው፣ ሪዱሲንግ ኤጀንት እንለዋለን። ሪዱስድ የሆነው ሰብስታንስ ኦክሲዳይዝድ ለሆነው ሰብስታንስ ኤጀንት ነው፣ ኦክሲዳይዚንግ ኤጀንት እንለዋለን። እሱ ሪዱስድ ነው፣ ሌላኛው ኦክሲዳይዝድ እንዲሆን ኤጀንት ሆኗል። ኦክሲዳይዝድ የሆነውም እሱ ኦክሲዳይዝድ ሆኖ ሌላኛው ሪዱስድ እንዲሆን ኤጀንት ሆኗል። therefore reducing agent እንለዋለን ማለት ነው። now let us see non-redox reactions. So far we have discussed oxidation and reduction reactions or redox reactions. However, there are also reactions in which oxidation and reduction do not occur. Such types of reactions are known as non-redox reactions. In non-redox reactions, no electrons are exchanged between the reacting substances. Therefore, the oxidation number of the atom do not change in the reaction. ምንድነው እዚህ ጋር እያለን ያለው? ነን ሪዶክስ ሪያክሽን የሚባሉ ደግሞ አሉ። እነዚህ ምንድናቸው? ኦክሲዴሽን እና ሪደክሽን የማያካሂዱ ወይም ኤሌክትሮን ትራንስፈር የማያደርጉ ሪያክሽኖች ነን ሪዶክስ ሪያክሽን ብለን እንጠራቸዋለን። ነን ሪዶክስ ሪያክሽን በሰብስታንሶቹ መካከል ኤሌክትሮን ትራንስፈር አይሆንም ነው የሚለን። In non-redox reactions, the oxidation numbers of atoms do not change in the reaction. Usually, such types of reactions involve the exchange of positive and negative ions. Most of the double displacement reactions and acid-base reactions are not redox reactions. እዚህ ጋር ምንድን ነው? እነዚህ ነን ሪዶክስ ሪያክሽኖች ፖዚቲቭ እና ኔጌቲቭ አዮናቸውን በመቀያየር ነው ሪያክሽኑን የሚያካሂዱት። እነዚህ ሞስት ደብል ዲስፕሌስመንት ሪያክሽኖች እና አሲድ ቤዝ ሪያክሽኖች ሪዶክስ ሪያክሽንን አያካሂዱም። For example, barium chloride and sodium sulfate takes place double displacement reaction to produce barium sulfate and sodium chloride. If you see when we see the oxidation number of each element, the oxidation number of barium in the reactant side is +2. The oxidation number of barium in the product side is also +2. The oxidation number of chlorine in the reactant side is -2. The oxidation -1. The oxidation number of chlorine in the product side also -1. Sodium in the reactant side +1, +1 in the product side. Sulfur +6 in the reactant side and sulfur +6 in the product side. oxygen -2 in the reactant side, oxygen -2 in the product side. There is no change in oxidation number. Another example, hydrochloric acid react with sodium hydroxide. It is hydrochloric acid is an acid, whereas sodium hydroxide is a base. This reaction is acid-base reaction. In the reactant side, hydrogen has oxidation number +1 and chlorine has -2. In the product side, also hydrogen +1 and chlorine -1. Sodium in the reactant side +1, in the product side +1, oxygen -2 in the reactant, in the product -2. There is no change in oxidation number. Therefore, these are examples of non-redox reactions. The first one is a double displacement reaction. The second one is acid-base reaction. Acid-base and double displacement reactions are most of the time non-redox reactions. ለዛሬ በዚህ ብቃን። በቀጣይ ኤክሰርሳይዝ 4.14 እናያለን። ላይክ፣ ሼር፣ ሰብስክራይብ አድርጉ። ለጓደኞቻችሁም እንዲያደርጉ ንገሩ። ለዛሬ በዚህ ብቃን። ባባይ